Welcome. Today we are diving into one of the most visible and, one of the most amazing stories of human evolution. It's a story that's literally written on our skin, a masterpiece of adaptation that's been sculpted by sunlight, by geography, and just by the raw need to survive.
So let's get right into it. This is the big question, isn't it? Why is it that our single species, Homo sapiens, shows off this incredible, breathtaking rainbow of skin tones? Well, the answer is this fascinating evolutionary tale all about a crucial balancing act. And that story starts with one single, really powerful pigment.
And here it is, melanin. This stuff is the star of our show today. You can think of it as our body's very own natural, built-in sunblock. It's made by our skin cells, and basically the type and amount of it you produce is what gives you your skin color. But its main job, evolutionarily speaking, isn't really about how we look. It's all about protecting us from the sun's powerful ultraviolet or UV rays.
But this is where it gets really interesting, because the sun is kind of a double-edged sword. It's both a threat and a total necessity. See, on one hand, way too much UV radiation can wreck the DNA in our skin cells, which can lead to cancer. So obviously we need protection. But on the other hand, our bodies have to get some UV radiation through the skin to produce vitamin D. And that's absolutely critical for strong bones and a healthy immune system. So you see the problem, right? Evolution had to find the absolute perfect balance between protection and production.
Okay, so let's start our journey at one end of the spectrum, in places where the sun is just relentless. In these environments, the evolutionary challenge was all about one thing: creating the strongest shield possible.
So, this skin tone? This represents the highest concentration of melanin that human evolution has ever cooked up. It developed in places like equatorial Africa, where UV radiation is just incredibly intense, all day, all year. The melanin is so packed in there that it creates this beautiful, deep ebony color, which can sometimes have these really cool, almost bluish undertones.
And this just lays out the advantages so clearly. This incredible amount of pigment acts like a super powerful shield, protecting the precious DNA inside your skin cells from getting fried by the sun. And that, of course, dramatically lowers the risk of skin cancers. In a place with constant, severe sun, this wasn't just a nice feature to have. The source material is clear. This was an absolute requirement for survival.
All right, moving just a bit along the spectrum from that maximum shield, we find rich, dark brown skin. You'll see this in places like West Africa and parts of South Asia. It has a slightly lower concentration of melanin than deep ebony, but it still offers incredibly strong protection. You often see these really warm, golden, or even reddish undertones.
So the key word here is really balance. It gives you this amazing shield against DNA damage, but because the melanin is a little less dense, it allows for a small increase in vitamin D production. It's this perfect mix of defense and flexibility. And this evolutionary story has real-world implications today. While it's fantastic natural protection, someone with this skin tone living in a place with less sun, like, say, Northern Europe, might need to be a little more mindful about getting enough vitamin D.
Okay, now let's move into the middle of the spectrum. This is where evolution really started showing off, crafting these tones that are just a masterful balancing act between protecting the skin and absorbing just the right amount of sunlight.
So here we're looking at tones like mahogany brown with its beautiful reddish coppery look, and light golden brown, which has that warm sun-kissed appearance. These are the evolutionary answers for parts of the world with plenty of sun, but where it's more seasonal. Think about places like Melanesia or around the Mediterranean.
You know what I love about this? That word dynamic. These skin tones are just so versatile. They've got enough melanin to give you reliable protection from sun damage, but they're also super efficient at making vitamin D when the sun isn't at its absolute peak. And a lot of these tones have this awesome ability to tan really easily. And tanning is just that. It's a dynamic response. It's the skin actively turning up its own protection as the sun levels change. It's just a phenotype that's perfectly tuned for resilience. Okay, let's break this table down, because it really shows how evolution solved the same puzzle in slightly different ways. So you've got olive skin, common around Southern Europe and the Middle East. It has these neutral, sometimes greenish undertones that give it what the source calls a camouflage effect. It looks darker in bright light and lighter in the shade, which helps regulate UV exposure. Then you have warm beige skin, more common in Eastern Europe and West Asia. It has a little less built-in protection, but it makes up for it by tanning pretty easily, creating its own protective layer during the sunny months. I mean, both are just brilliant solutions for living in seasonal climates.
All right, for the final part of our journey, we are heading north. We're going to places where the sun is a rare and precious thing. And here, the evolutionary challenge completely flips on its head. It's not about blocking sunlight anymore. It's about capturing every single last ray you can get.
And that brings us to fair light skin, which mostly developed in Central and Northern Europe. The really low levels of melanin give it that pale beige or kind of pinkish look. And you can see why, right? A high concentration of melanin here would actually be a disadvantage. It would act like a barrier, blocking the very limited UV light that's available for a huge chunk of the year. So the most important thing to get here is that the advantage of fair skin isn't protection, it's efficiency. By having less melanin, the skin becomes incredibly good at soaking up whatever little UV radiation is around. This maximizes vitamin D production, which was absolutely vital for preventing diseases like rickets and, frankly, for surviving long, dark winters. Of course, the flip side of all that efficiency is a much higher vulnerability to sun damage, which is a really important health consideration for fair-skinned people living in sunny places today. It's all about the environment.
And now we're at the furthest end of the spectrum, where we find very fair skin. This represents the lowest concentration of melanin found in humans. It developed in places with the absolute least amount of sunlight, like Ireland, Scandinavia, and the Baltic regions. The skin can look almost milky white or even a little translucent.
I mean, this is basically adaptation taken to its absolute logical extreme. Yeah, it's highly vulnerable to the sun, but that vulnerability wasn't a disadvantage in its home environment. Not at all. Instead, this incredible efficiency was a precise survival mechanism. It guaranteed that even the tiniest amounts of UV radiation in those post-glacial environments could be turned into the nutrients needed for strong bones and healthy kids. It's a masterclass in making the absolute most of a scarce resource. So, after traveling across this whole beautiful spectrum, let's just zoom out for a second. What we've seen isn't a story of different categories or types. It's a single, continuous story of human ingenuity, resilience, and incredible adaptation. And this really just sums it all up perfectly. Our journey started with high melanin, which gave us a maximum shield near the equator. Then, as humans migrated across the globe, medium melanin evolved as this flexible balance for life in seasonal climates. And finally, low melanin came about as a tool for maximum absorption in low-light regions far from the equator. And it's so important to really grasp the timescale we're talking about here. This was not a quick fix. This intricate, elegant dance between our skin and the sun played out over 1.5 million years. It's a story written across tens of thousands of generations.
I just love this quote from the source material because it nails the essence of everything we've been talking about. Every single skin tone is a phenotype. It's the visible result of genes and environment that is finely tuned for the exact challenges of its environment. It's about balance, it's about the mobility that allowed us to populate the entire planet, and it's about the incredible resilience of our species.
So, I'll just leave you with this final thought to chew on. If every shade of human skin is simply a different, brilliant solution to the exact same environmental puzzle, what does that tell us about our shared human journey? It kind of suggests that our differences aren't divisions at all. In fact, they're the very evidence of our collective success. A single, amazingly adaptable species that has now built a global world where these ancient adaptations are interacting with new environments every single day. Thanks for watching.